Hello kids, this is Mr. M and I'm here to talk to you more about probability today. Now probability is a really cool math concept because you could use it every day. You could use it to help you in sports, you could use it to predict the weather, and also last year when I went to Florida, I flew all the way out there to watch a space shuttle launch. Now sometimes the space shuttle launches that they go off and sometimes they're canceled or they have delays and sometimes it's because of the weather or there are some mechanical difficulties. So what we're going to try to calculate later is what's the probability that you actually see a space shuttle launch on the first time. So that's something that we're going to have to think about. But before we get into that, let's go ahead and do a little bit of a review of what we had done last time. So probability. So probability is the chance or likelihood that something is going to happen. Like, what are the odds that an elephant's going to show up in this room? Not very likely. Okay, good. Just checking. So when we're doing some calculations, we want to go ahead and figure out how we do that and write that for our equations. So for our equations, what we're going to do is we're going to look at the denominator numerator. It's like a fraction. On the bottom is the total number of outcomes that we're going to have for an event. On the top, it's going to be the total number of times something is going to happen. Let's look at some examples to figure out what this means, all right?
So our first example is looking at a coin. So a simple coin has one side heads and the other side is going to be tails. So we're going to have two options to work with here. So let's see. We have heads and tails. So we have two sides. And then the one we are caring about is going to be heads. So we want to know how many times it's going to land on heads if you flip the coin. So we'll do that by saying it's a 1-to-2 ratio. And you can also write it as a fraction, 1-to-2. Which is also the same as calculating this out. 1 divided by 2, calculate it over, put the numbers in there together, we get a 5, 0, so it translates to 50%. There you go. So 1 to 2 or 50% chance that you're going to land on heads when you flip a coin. All right, so let's look at a different example. Here's a bunch of coins. And I want to find out how many coins there are. So counting them, there's 12 of them. And I want to know what percentage or what's the likelihood of me grabbing a penny by random. So I need to go and count those pennies, put them in a circle. There's 4 of them. And we're going to go ahead and say that's a 4-to-12 ratio. Or you can put it into a fraction form, which is 4-to-12. Now let's decompose that really quickly here. You got 2 and 2, 2, 2, and 3. Those 2 and 2s make 1s, and so you have 1/3 remaining. So we have 1/3 remaining and the 4/12. Those are the same, and then we're going to calculate the percent, 33%. So there's a 33% chance of grabbing a penny at random from this group of 12 coins. All right, very good.
Great. Now that we have finished our little review, let's try mixing it up a little bit. What if you have 2 items to use? So let's think of a coin and a die. What are the different options or different probabilities you come up with using that? Let's go ahead and find out.
So it's a little more complicated with two objects. First you have a die with those 6 sides on top. There we go. And you have a coin which has 2 sides and heads and tails. And so what we're going to do is look at the combinations. How many combinations do we have? So we have a heads with 2, heads with 3. We could have a heads with 4. So all these different combinations. Heads with 5 and heads with 6. Now you could also do the same thing with the tails and just go ahead and quickly just match those up together. Everyone can see how that works. Yeah, tails with all the different combinations of the dice. So let's list them down. We have heads first, and we'll pair it up with the 1, and then pair it up with the 2, so heads, and we'll write 2, heads and 3, and heads and 4. Now, what do you think comes next in this list? So we have heads through 1 through 4. The next one is going to be what? I know you're thinking it. That's right. It's heads with 5.
So we started writing a list of all the combinations you could get using a coin and a die. Can you finish the list on your own? Go ahead and take a second to write it down. Remember, you're going to write all the combinations of a die, that's 1 through 6, and a coin, which is heads and tails. So go ahead and finish your table. I'm waiting. Just write it down. Okay, good. Now let's take a look at this.
Well, here you go. Here's my list. It's all the combinations from flipping 1 coin and 1 die. And so you can see here that it's all heads and all tails. And then now I'm going to pull out a 6 here because I want to know what the percentage or what the likelihood of getting a 6 out of all this combination. So when we do a probability, we need to know how many options there are. So the total number of options is 12. And then we need to count how many times 6 appears. So let me look. It's right here's 1 and right here. Tails and heads with 6. So 1, 2. That's a total number of 2. So let me see if we calculate that out. We're going to divide and try to figure out what the decimal form of 2 over 12 is and calculate it out. 0, 8 in the denominator, drop it 72, and calculate that out. It's a 6. Oh, we're going to get 6s all over the place. So let's go ahead and say it's 16.6%, or we'll just round it up to 17. 17% chance of getting 6 on your die when you flip one coin and roll one die.
So now we're talking about tree diagrams. Now, why do we call them tree diagrams? Well, it's basically because on each little step, you have the different options that they branch out to how many options you have. So if you have a coin, you have 2 options, and then if you have something with 4 options, it spreads out even more. So, and then another thing, if you take the diagram and you twist it, and then if you add a little color to it, and then your drawing looks more like a tree, doesn't it?
So here we go. We have our 1 die and 6 sides, and we have our 1 coin and 2 sides. So let's write that down. 2 for the coin, and 1 die. We're going to have those 6 sides written down, each of the numbers. And then we're going to go ahead and put together our tree diagram. So we're going to start off with a little question mark. And then you first divide it by 2 because we're using the coin. So one's heads and the other one's tails. And then we're going to look at the dice, and there's 6 options. So I need to go break this up into 6. 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. Label that really quickly there. Get that down. All right. And there you go. That's my tree diagram for flipping 1 coin and rolling 1 die. How do you like that? So what about if we take and do 2 coins? What do you think that's going to look like? I want you guys to go and think about that and try it. You guys should have your paper and pencil. Write that down. Here we go. We have our second coin. We're going to have more options. So how do you think that's going to look? Ta-da! There you go. That's what a tree diagram looks like for 2 coins and 6 die. Is that what you expected? Hopefully it is. So let's rewind now and go back so I can break down to you what this is supposed to look like. Yep, just gonna erase there, take care of those, and now we're going back to the beginning. Okay, so we have 1 coin. We're gonna break into 2, heads and tails. And we're gonna, for the next coin, we have to break it into heads and tails, but since there's 2, yes, there's going to be 4. So 2 times 2 is 4. And then now we have those 6 for the die. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Yes, you have to do it for all of them, and then we label them, all the numbers through there. Let me write as fast as I can, get that done. And ta-da! There you go. That is the tree diagram that we're supposed to look at. Now, each one of those lines represents a certain combination. So we have heads, heads, and roll the die of 1. So if like you flipped it a couple times, you get these different combinations. So I'm just pointing out a couple here. So this is heads, tails, and a 3. And this last one here is you also get tails, heads, and 6. So you see if we go back here, you go down tails, heads, and a 6, and that's how you get to that spot. So there's actually all different ones. What about this one? What do you think that one is? Come on, you can tell me. Yep, we're going to tails, and then we're going down to another tails, and then going down across the number. Yes, we're going to add a 4 for the last one. Very good. So those are all the different combinations.
All right, so we have one more example to go through. Let's go.
Okay, we're back again. So we're trying to find out what is the probability of H and 6. So 1 heads and a 6. So let's look down here, and we have 24 options, and we're trying to look for a heads and 6. So that's one combination. Ooh, there's a heads and a 6, and a heads and a 6. So I have 3. Do you see any more? No, that's it. 3. So 3 and 24. Okay, let's calculate this out. Quickly, we'll decompose that. 2 and 2, 2 and a 3. Those 3's combine to make a big 1, and so we have 1 over 2 times 2. That's 8. Yes. All right, so we have 1/8 now. So let's go ahead and do the math on that. 8, 1 divided by 8. Going to put the number in there, calculate it out, drop a 0, and yes, we're cutting it 2 and 4, and that's 5. Okay, so very quickly, we looked at the numbers. It's 0.125, which is 12.5%. Great, and that's the probability of getting heads and 6.
All right, so now let's talk about area models. For area models, you always start off with a square. Now the square is used to figure out what the proportion is. So the square is the entire area. So the first thing you do is you look at each of the top sides and on the other side, and you divide it by the number of options that you have. What do I mean by this? Let's go ahead and take a look at some coins, all right? Let's look at one coin. So for one coin, you have the option of heads and tails. So now we could go and divide the square by 2 because there's 2 options. So now you see that the square is divided by 2. Now let's look at our other option. Since we have 2 coins, we're going to have to do 2 things as well. So again, the options are going to be heads and tails. And we're going to go ahead and divide the square into 2 again because we have 2 sides. All right, great. So now our square is divided all up. So can you tell me, how many options, how many total outcomes do we have when we flip 2 coins? What do you think? You're right. It's 4. There's 4 number of sides. Let's count. 1, 2, 3, and 4. 4 different options. Now, when we're looking at probability, what about how many times does heads and heads come up together? That means getting 2 heads, flipping heads twice. So if you look at the boxes, how many options do you think it is? All right, let's see. We have one option that's heads and heads. All the different other combinations are not counted. So the probability of getting heads is going to be 1 out of 4. Because there are 4 total squares, and one of them is heads and heads. Got it? Let's go try another way.
All right, so this time we're going to try 1 coin and 1 die again. So let's make our square as we start off this area model, and then we're going to start with the coin. So there's 2 options with the coin, heads and tails, and so we're going to put that there, and it's going to be 1/2 because there's 2 options. Now we have 6 choices on top for the die here, and so what we need to do is divide this into 6. So here we go. Draw these lines. They're roughly 1/6 each. There's 1 out of 6. Okay, so now we can fill these in. So this is going to be heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6. And oops, nope, that's a tail. Tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. So those are all the combinations that we have for rolling 1 die and flipping 1 coin. So now what are we going to do if we want to have an even die and heads for your coin? So let's go ahead and count the options here. 1, 2, 3, that's 12. And then how many spots are even? So let's see, that's an even one, that's an even one, and that's an even one. And those are all heads. So it's again 3. So let's decompose our fraction into this prime factors. There you go. And you take those 3's and that makes a 1. So you have 1/4. and that equals 25%. So there you go. The chances of getting even and heads is 25%. All right, congrats guys. You did a good job so far. So we're gonna try to do a fun problem. We're gonna have some yogurt at the yogurt shop, and they have a special deal for us.
Welcome to Yogurtland! You've won a special cup. Choose between 3 flavors and 5 toppings. You get 1 each.
How cool! So I'm gonna get this special deal at the yogurt shop. They're gonna give me 1 of each category. So in yogurt, I have 3 categories, and for the toppings, I have 5 options. So I really love chocolate. So I'm hoping to get chocolate or chocolate chips or maybe chocolate brownies. But they're gonna give me only 1 of each. So I need to figure out what the probability is that I'm gonna get chocolate in my combination deal here. So let's go ahead and see how we could calculate this out.
So now that we have our problem set up, let's go ahead and use our organized list, our tree diagram, or our area model to figure it out. You choose which one is easiest for you to use. I'll go ahead and put that up on the screen here so you can see it. Just pick one of them. Go ahead, now we're solving for 3 and 5. List, tree, area model. Okay.
Alright, so while you guys are working on your drawings, whatever model you chose to do, you might want to pause it because you might not have enough time, and then come back.
Well, I'm just about finished up. I hope you are too. Let's see. What are your options? Does it look like this?
Well, here you go. Here are the 3 options. You have the organized list, the tree diagram, and the area model. So the organized list lists the flavors first, and then the toppings, all the combinations. And then you have the tree diagram, which has the 3 flavors, and then broken up into the 5 toppings. And the area model, which is just the box that is divided 3 and 5. So you're going to have all those things put together. Alright, so we have all the options with the chocolate highlighted. I love chocolate. And now our big question is, what is the percentage that the chocolate is going to appear if I randomly get a combo? So I need to count the total number of outcomes, which is 15. And then the number of times that chocolate shows up is going to be 19. Now we need to do a little division here, so I'm going to take the denominator and it's going to throw the numerator into a box. So 15 throws 9 into a box, and then we do our little calculation here. 0, and we find out 15 goes into 96 times. Yes, calculate that out. 0.6 equals 60%. And so 60% is the amount of time that we are going to have chocolate in our dish. That's great. And so it's the same as 9 out of 15, or 0.6. Good deal. Good job, everyone. We get chocolate.
All right. Are we all ready to go back to Florida now? Let's think about that launch for a minute. So I want to find out what the probability that a launch is going to happen. Now, while I was out in Florida, I heard this news report.
Delayed. While Atlantis is ready to go on Launch Pad 39A, the weather is dicey. NASA says the chance of a Friday morning liftoff is no better than 30%.
Now, listening to the news report, they said a 30% chance of the launch going up. That means that there is a 70% chance that there is going to be bad weather. Also, I was talking to some engineers at NASA, and they said that 35 out of 100 times, they usually have to cancel or delay a flight because of mechanical problems. That means something is wrong, they have to fix it. So there's either 35% chance that it's not going to work, but 65% of the time, they are okay. So now we have 4 numbers to deal with. We have 35% that it's broken, 65% that it works, and then we have 30% chance that it's good weather, and 70% chance that it's bad weather. Can you guys use those numbers to figure out what the probability is that I'm going to be able to watch the space shuttle launch? So let's think about it. You can use an organized list, you can use a tree diagram, or an area model. What do you want to use?
Well, here are your options, and this is a time you might want to pause the video so you have time to write down all your answers. But here you go, organized list, tree diagram, or area model.
Okay, so now you have all those choices. Let me show you what I got.
Decided to use an area model. I didn't do an organized graph or tree diagram. I just wanted to use a model, so I made a box and then I divided it up by the options that I had. So the 35, 65, 70, and 30. So let me break it down for you here. So we have first the weather delay, which is 70%. We got from the newscast, and that's for bad weather. So I put bad weather 70% and then good weather 30%. And then want to make sure I add the mechanical delay from the engineers, and they said it was 35. If it's broken, 65% that everything works. So in order for you to have a blast off, you need to have it to work and have good weather. Both of the conditions have to be true. So we look at that 65 and that 30%. So let's put 65 and 30% so we can calculate the total percentage. We'll multiply these two numbers together. And then we're going to have a 0, calculate that 0 again, and then 3. So we're going to 5 and put a 1 over there, 9 and 1. So you need to add all these things together. Make sure your units are in the right spots. So 0, and then we have 5, and then we have a 9 and 1. Okay, so then we have our decimal places that moved over 2. So we want to make sure we do that. 1, 2, 3, 4. And so it matches. There you go. There's our decimals, 0.195. And then we're going to make it into a percent. So you need to multiply that by 100. And then multiply that out. We get 19.5% chance of being able to watch a liftoff, which is actually not very good. And actually, when I went out there, I didn't get to see a space shuttle launch. But the good news is that we did the math correctly. Yay!
All right, everyone, good job today. We learned a lot about probability. We learned about how to do complex problems using organized lists, tree diagrams, and also area models. So hopefully you'll be able to use this when you solve probability problems in the future. So as for now, it's Mr. M signing off. 3, 2, 1.
Lift off. Whenever Atlantis blasts off, it will be the 135th and final shuttle mission.
I mean, I guess you could go here now.
No, I got you.
We can do it from there?
Yeah.
Okay. Get ready. Stretch.
You always need to go.
What? Makeup? No, that's okay. This is Mr. M, and I'm here to talk more about probability today. Alright, we got this. Alright, kids, good job. I've had too much yogurt. Oh, and don't forget, have your paper and pencil ready. I could probably cut that out. We really don't need to tell them to get their paper and pencil. They're in school. You should know what your paper and pencil are. You should have it with you, along with your calculator, unless you don't have calculators in class. You could use your abacus. 1, 2, 3, 4, 5.
How did you want me to color this? Just like color?
Yeah, however. Like a tree.
Okay.
Put a little brown. You got a little brown there? Throw a little trunk in there. How about some bird action? Some little animals? Clouds, maybe? Yeah, there you go. That's nice. Right over here. It's like I'm the weatherman. Look at the birds. I've already moved. I've already destroyed the tray. Oh well.
You might need another sheet diagram.
Should be good enough. That should be good enough. Yeah?
Yeah.
And then your drawing looks more like a tree, doesn't it?
One more time. Do it again.